is Nikhil. I'm a recent grad from Northeastern University, completed my master's in computer science. I've done around 113 lead code problems. This is my week 2 in Head Start, and I was building an autonomous machine learning agent, which is essentially an end-to-end automated ML pipeline orchestrated by large language models. So the problem currently we have is traditional ML pipelines are manual, repetitive, and error prone. So we require expert input for cleaning, model tuning, and evaluation. So this slows down experimentation and scalability, limiting cost to ML adoption for data scientists and the entire data and ML team. So this is the solution. Uh, Introducing autonomous ML agent, which is orchestrated by large language models. So we are I thought of around 4 agents. One is for data pre-processing, second to tuning, third is evaluation and selection, and then deployment. So this is the usual solution which a data scientist would do or a ML engineer would do in production, but we are utilizing LLM orchestration so that we can automate the entire process and make the best decision out of it. And in the end, the solutions or the entire code, we should get a report or explanation via the LLM itself, so that we can back up the decisions which it made. So the key features of these solutions are LLM orchestration, which essentially generates the codes and dictates which agent will work when, and whenever the code is generated, we are creating an E2B sandbox execution. So these are virtual sandbox especially created to run LLM generated code. So these are safe and they can run in safe and isolated environment. Once we do that, we create a leaderboard of all the models with the best matrices and best performing matrices, and then we try to use interpretability or feature importance to make sense of why a certain model has performed better compared to others. And this will go around a loop so that we can improve as we go along. So the benefit of this is the faster iteration. We are essentially automating repetitive tasks which are being done by ML engineers or data scientists. This is scalable, works only on tabular dataset. So that's one of the benefits of that. When it comes to tabular dataset, majority of the workflow is a very automated process, so it can scale up depending on the number of rows or number of columns. How it depends how we are scaling it up. And another benefit is that it is transparent, since in the end we are generating LLM based explanations. We are trying to create a report which essentially tries to say what why the model has performed the way it has. So this is the entire workflow, and show you what I have made till now. So this is my automatic ML agent. I have utilized Streamlit to create a web application or a user facing application. Over here I can upload a file which is specifically CSV only. So I'm uploading churn.csv file, and this is a preview of the dataset which you can see over here, and this is a select column to predict. So depending on the column we selected, it detects whether the task will be classification or regression. So for example, I have currently selected exited. If I select credit score, it will change to regression, and that will change things up. So that's one thing. And then we have 3 options: clean data only, train models only, and full pipeline. So full pipeline basically runs everything up and in the end shows what models are being done. So I will just hit full pipeline for now. So we will be first performing data cleaning. So I will take you to the code as well. So yeah, here's the starting over here, and then we are, this is a small helper function to summarize the entire data set and other things. So this is more like information which we are passing, which will be passing to the LLM. So and this determine type task is essentially checking the cardinality, basically checking unique value present in the column, in the target column, and we'll see whether it's a classification or regression problem. So that is one thing. And then next we are building clean prompt. So this is one of the prompts which I have tested, which worked very well when it comes to cleaning or pre-processing the data set. We'll use this one, and then we are doing the, and let's skip that for now and let's see. So I'm using DeepSeek API for current as our LLM, and I'm I'm telling the LLM to give me the script basically in a JSON format with the property name script, and then I will fetch the entire value as the message given returned by the LLM. Once we do that, we are performing two actions. So one is first of all is the cleaning in E2B. So we need to create a sandbox in E2 using E2B, and this virtual sandbox will essentially run. These are more like ensuring whether it exists or not, and the folders exist or not, because I faced a couple of problems while dealing with that. So essentially what we do is we take the input, store it in the sandbox, and once we have that, we'll run the code which was generated. We'll run the script and store the result in result variable, and then make sure to save the result as clean.csv in the temp folder of E2B sandbox. So once that is done, essentially cleaning is done, and similarly for train also using E2B again. This will take input as the clean CSV file which we already generated, and then basically we will perform we'll store all the different results from the models in the results variable, and store it in a JSON format. So in that in the end we can fetch the training results. So that's the way we are training it, and yeah, this is the cleaning. Okay, this is the cleaning one. This is the E2B. E2B is done. Then we have validate script, which helps in checking whether the names presented in the prompt were validated or not. This is workflow and display workflow. This will come when a good threshold has been maintained by the trained models, and if they are maintained, then only that display will be done. And this is the Streamlit code which I'll just go through. Basically a summary of all the results, and so that is the entire project for now. Yeah, and these are the future scope, which were actually this. The first one was actually a deliverable which I wasn't able to do in the time being, which is creating reusable artifacts, so a fast API service or a Python package, so that users can interact with the tool and use the best performing model as the machine learning model, so users can query or play around with. And then we can expand it to unstructured data like images, text, audio, which are not quite that straightforward, as it's unstructured and not structured, so we will need to think in a different direction for that. We can integrate active learning for continuous improvement, add it to auto deployment on cloud, and build a UI for non-technical users. Currently it's very technical users heavy. So that's it for now. Thank you.